All right. The reason why we're looking at earthquakes is we know that they can alter the land and they can do some damage to some man-made structures, et cetera. And so we need to look at what exactly causes that today, what leads to more damage than others. You're going to be taking notes on this part of your note sheet between here and here. So please make sure if you have to pause or back up or do anything to make sure that you get all those spots filled in, do that. All right. So there are three things that can increase damage to a building during an earthquake. And number one is the distance from the epicenter. If an earthquake happens in Japan, we don't worry about it here, but people who live in Japan do because they are a lot closer to it. So the closer you're out of the epicenter, the more damage there is, because we know at the epicenter that's where the strongest shaking occurs. Okay, and then the type of soil it's built on. I already made mention to loose, poorly compacted sediment, silt, sand, clay, that sort of stuff. Terrible for building buildings on and expecting them to hold up to earthquakes. Bedrock is the best surface to build a building on and have it be earthquake resistant. The other way is how you design the buildings. Are they earthquake resistant or not? This picture right here shows a building that is made of bricks. And in the brick buildings, a lot of times you've seen bricks, they have the holes in them. And the reason why they put the holes in them is so they put steel rebar through, because if the mortar holding them in is the only thing holding them on, then when there's an earthquake, that mortar can crumble out and then the bricks rain down on the street. And in this picture, you can see a red, a blue, and a white car under a bunch of bricks that fell off that building. So you want buildings that have bricks with rebar in them that are reinforced. That's one way to build them building resistant. This one in San Francisco, the building is built on top of the garage to save space, but also because the supports of the garage then move and the apartments sit on top of that and they don't have to absorb the shaking. So if any damage is done, it's done to the cars and not the places where people are at. They don't just damage buildings. You can damage bridges and dams, and this can lead to falling debris, fires, because you can break gas lines, and flooding, and loss of life. So this is another picture of that Interstate 880 from the 1989 Loma Prieta earthquake. I always think that this person driving the truck right here was very, very lucky in the section that didn't collapse. Okay, so how do we determine the earthquake strength? There are three different scales that we use. One is the moment magnitude. This is really the one that's used today, and it's basically estimate of energy based on how much the ground moves. Did it move an inch? Did it move a foot? Did it move 10 feet up or down or side to side? And that can be translated into energy released and tell us the magnitude of the earthquake. The Richter scale was the way that we did for a long time. And basically that just had to do with how high the highest S wave was on a seismogram, and then that gave you the magnitude of the earthquake. The problem is that some earthquakes were so big and the seismogram needle couldn't go up high enough to record that, so sometimes we got inaccurate measurements. And the other one is the Mercalli scale. The Mercalli scale is used for historic earthquakes that we did not have a seismograph around to make measurements with. So they basically use observations like this chimney collapsed, or these books fell off the shelf, or this building fell down, the bell rang at this church or whatever, and that allows them to calculate what the magnitude was of historic earthquakes. Okay. One of the main reasons why we look at earthquakes is that they change the land. These ground vibrations, they really affect poorly compacted soil, so sand, silt, clay, by causing these materials to shift and move and settle, which then, of course, affects whatever's on top of them. These pictures here are from the largest earthquake that happened in Montana history, which is a 7.5 magnitude earthquake, which is a very large earthquake. And what happened, it was west of Yellowstone, just into Montana, near this area called Hebgen Lake. And you can see in the black and white picture that what happened was, when this earthquake happened, it caused this side of the hillside to fail and slide across over to the other side, cutting off the Gallatin River. It's 400 feet of rock and debris that was piled up there, and this river was forming new lake, which hadn't existed before. The Army Corps of Engineers had to come in and cut a spillway out of that so it wouldn't flood the valley down below. You can see on the picture on the right, caused roads to collapse and houses and trees to fall into the new lake, which is now called Quake Lake, conveniently. And just some crazy stuff happened during that. Like a 70-year-old lady, her home was tipping into the lake. There was like a 6-foot gap, and she jumped across to safety during that earthquake. So just some wild stuff. All right, so what are some land features that we have as a result of earthquakes. One is called a slump. You can see that here in the black and white picture. It's basically just a piece of land moving a little bit downhill because it's been weakened by the shaking. You're familiar with landslides. This is in Southern California, very steep slope, lots of rainfall, get an earthquake, and it tends to fail because it's so steep and the material is loose in it and has been weakened by the earthquake. We can also get a scarp. You can see this on the top here. This looks like a step, and basically what you have is two sides of a fault, and one side lifts up and or drops down, and that creates this kind of step feature. In Montana's largest earthquake, it created a scarp in some places that was 22 feet tall. So it wasn't there before the earthquake happened, and all of a sudden there's a 22-foot step. So that's a pretty big scarp in a large earthquake. And then a fissure, this is a crack opening up in the ground. This is in Anchorage, Alaska, from the 1964 earthquake that happened there. Large, miles long, several feet deep, big crack opens up in the ground. Some land features that are formed by that. One other thing that happens as a result of earthquakes, how it can change the land, is called liquefaction. Liquefaction is exactly what it sounds like. It means the water in the ground causes the ground to become very unconsolidated and act like a fluid, which can cause buildings to suffer more damage, or in this case, cars to sink within that surface, which is now acting like a fluid instead of a solid. So pretty wild. Okay, what you're going to do today is look at some Montana earthquakes that have happened in our valley and around the state, and look at some of our history of earthquakes. That is PDF. You'll have to use Kami and then submit that to the Google Classroom. Good luck.